1 over x minus 1 dx. Okay, let's talk about this. Does anyone have any suggestions? And let me ask a question before you answer that. What do we do first when we're asked to find a definite integral? What is the first thing before we even look at or take our marker or pencil or pen to write? What is the first thing we do? We inspect. So let's inspect this. What is the requirement for a definite integral? Anyone remembers? Under which conditions I can apply the fundamental theorem of calculus? When is this applicable? Anyone remember that? Well, the answer is when f of x is continuous on the interval a comma b. A comma b. Is this function continuous on the interval a comma b? This is the first thing we need to check all the time. It's like the idea with the limit, right? The limit of a function as x approaches a, we have to see what type of limit this is. So we always plug it in. So see what it is. Maybe it's 0 over 0, maybe it's infinity over infinity, who knows? Maybe it's just 5. So is this function continuous on the interval -3, 2?
No.
No. So I will say FTC not applicable. The next one is an integral from -2 to 6 from f of x dx. But we are given the function, it's a piecewise defined function. And this is e to the x for x less than or equal to 0, and it's x squared minus 6x for x greater than 0. And we learned that there is a property of the definite integral. As you see, this function breaks, if you want, changes from this to this at 0. So therefore, we have -2 to 0 plus the integral from 0 to 6. Of course, dx. The question is, what do I put here and what do I put here? Any suggestions?
Is the first one going to be e to the x?
Absolutely, very good. And of course, we have x squared minus 6x. There is no need to separate them, and it's not a mistake, of course. So e to the x from -2 to 0 plus x to the third over 3 minus 6x squared over 2 from 0 to 6. Now be very careful, because when you plug in 0, you do not get 0 for e to the x. You get 1 minus e to -2. You do get 0 when you plug in 0 here, but you have to plug in 6 first. Plus 6 to the third over 3 minus, so this is 3 here, 3 times 36. If you leave it like this, I'm fine, and you get 100%. What I got was -35 minus 1 over e squared. But again, you can just leave it alone. Okay, any questions so far? The next one was the integral from 1 over 4x plus 7 dx. How do we start? Any suggestions, any comments on this one? What is our starting point? What do you think?
Do we still check for continuity on that one?
No, because it's not a definite integral. Very good point. The function has to be continuous on the on the given interval. We don't have an interval here. So continuity is not necessary for an indefinite integral. Good. So what will be the next step? I know you know because we had way more complicated situations in class than this one.
Do we have to somehow separate it?
Can you separate the denominator into two terms, one into something? The denominator doesn't work. It's carved in stone.
Mhm.
We can't separate. We can separate if we have, like, say, x squared plus 2x over 3. Yes, this I can. X squared over 3 plus 2x over 3. But here I have two terms. Terms in the denominator cannot be separated. In the numerator, yes. If I have just one term in the denominator.
Is that
Okay.
what we use? We use the substitution for u.
Yes. What is it? Excellent.
4x plus 7.
Very good. Because du is in the problem as 4 dx. And I showed you this little little shortcut because it's only a number. If it's more than a number, then I will probably have to solve for dx. But this is just a number. I can multiply by 4 and divide by 4. This is 1. I didn't change the problem, but now this is the du and this is the u. So therefore, from here, we have 1/4 du over u. Perfect. Now what do we do next?
The antiderivative.
Good. Excellent.
ln of u.
Careful.
Absolute value.
Excellent. 4x plus 7 because it's u and I have to put it back in. That's it. Excellent. Well done. So now the last one here was x squared e to x cubed dx. Okay. Any suggestions?
We'll still use the substitution rules for that one.
Perfect.
X squared.
It will not work because then I have 2x dx.
Oh, that's right.
I will not be able to make this up.
X to the third.
Yes, x to the third. This is what we want to get rid of. This is the problem. And now du equals 3x squared dx. A minor factor I can always make up. Nobody cares. Multiplying by 3 and dividing by 3 will not change anything. But this is this. So 1/3 e to u du. All this is in your notes. If you go back to your notes, you will find those with different numbers slightly. So it's 1/3 e to u plus a constant c, and I have to go back, and u is x cubed. Very good. Any questions on anything? It's okay to start with something and then say, oh, I don't think it's the right one. It's okay. That's why I'm not going to erase it. It's okay. Say, okay, and then you realize that actually this is the problem. So, and you can cross them out like that. You don't even have to erase them from the test. I know you're thinking first you thought about this and then it didn't work, which is okay. And then you said, oh, actually it should be x cubed because then I have 3 and I can make the 3 up, the 3x squared dx. That's not a big deal. You may not see what the substitution is. More than one substitution may work also. But you may not see it from the beginning, which is fine too. Good. Other questions? Anything else you would like to go back to? Anything else from the test or otherwise? And if not, we're going to pick some topics and discuss anything you like. So any other questions from the test? Anything else you'd like to go back to? Which part was difficult from this test, you think? Or were the differential equations clear, or was that any difficult? Any difficult problem, or did you encounter anything? Please talk to me, please. Okay, anyone? Would you like to pick a topic? Would you like to pick a topic to start with? Anything from from test 1, anything from test 2? Anything?
I would like to see something from chapter 4.
Okay, very good. So chapter 4 was on this test.
Sorry, actually from chapter 5.7.
So those are the differential equations. So do you want to go over anything in particular, or do you want us to pick?
You can pick something, please.
Okay. So I'll pick. You can also open at 5.7 and we can work on any problem. It's page 536. I'm going to start with, let's say 34, and you can choose the next one. So 34 on page 536. 536. Okay, so this is 3y squared dy over dx equals 8x. Is this okay? Would you like to pick something else? I mean, I can open my lab math and we can choose from there, or is this what you had in mind? Manny, is this okay?
Yes, we can work with that. Thank you.
Okay, so you can open it here and you can choose anything else. Okay, so remember we have to separate the variables. So these are okay here. So I will multiply both sides by dx. You can keep the 3 here for now, or you can divide it, but this will be useful if I keep the 3 on that side this time. So this is 3y squared dy equals 8x dx. As you see, because we multiply both sides by dx. As you see, this side has only y, this side has only x. Now I will integrate. Both of them should come up with a constant, but instead we are not using a constant here and a constant here. We're just keeping one constant to the right. So this is 3 and y cubed over 3. I should write plus c, but instead I will write 8x squared over 2 and combine these two constants into 1. Okay, of course the problem here is asking us to find y. That is the question. So I'll simplify. I'll also simplify here. So this is 1 and 1. So then I have y cubed equals 4x squared plus a constant c. At this point, I will take the cube root. The cube root does not have plus or minus. The square root does, the fourth root does, and so on and so forth, any even. Those will come up with plus or minus. But the cube root, the fifth root, no. So this is y equals the cube root of 4x squared plus a constant c.